Remember that in the Bronsted-Lowry definition, acids like to donate a hydroxide ion and bases like to accept it. Well, what happens is the acid will donate a hydrogen, but it's just left there, and as a result, it's attracted and it really wants a hydrogen. So as a result, this acid will turn into a conjugate base. So the acid turns into a conjugate base. And the same thing happens to the base. It receives a hydrogen, and now it wants to get rid of it. So it turns into a conjugate acid. So what happens is what was the base now is an acid and wants to get rid of its hydrogen. And what was the acid now becomes a base and wants to accept a hydrogen. This sounds complicated, but we can look at it with a few examples. So here we have HCl plus water is in dynamic equilibrium with H3O plus and Cl minus. So what we can see here is that hydrochloric acid donates its hydrogen to this water and it becomes H3O and Cl is left by itself. So we can see that because HCl donated a hydrogen, it is a Bronsted-Lowry acid. And we can see that H2O received a hydrogen, so that makes it, so received or accepted, so it becomes a Bronsted-Lowry base. So now that HCl donated its hydrogen, now we just have a Cl left. And as a result, the Cl is negative, it just wants a hydrogen. It became a base. So as a result, we can say that the Cl minus is a conjugate base. On the other hand, this H3O, now it has an extra hydrogen, and it wants to get rid of it just like an acid would. So now it is a conjugate acid. So we can see what was the base became the acid, and what was the acid became the base. Let's try this again on another example. Here we have NH3 plus HCO3 minus is in dynamic equilibrium with NH4 and CO3 2 minus. So let's see who receives and who accepts a hydrogen. So here we see that NH3 becomes NH4. This means it accepts a hydrogen. So as a result, it becomes the Bronsted-Lowry base because it is accepting a hydrogen. HCO3 donates its hydrogen, so we can say that this is the Bronsted-Lowry acid. So now that NH3 has turned into NH4, it wants to give its hydrogen away. So as a result, it becomes a conjugate acid. Because remember, acids like to donate their H plus ions. And here we have CO3 2 minus. Now that HCO3 gave away its hydrogen, it wants one back and it wants to accept a hydrogen. So as a result, it becomes the conjugate base.